now. All right. First thing you're going to do is a basic combination one. Let's do like 8, choose 3.
This is basic, Mr. So I don't know how to do this.
Great. Pay attention then. So, by doing it by hand, you do 8 exclamation point over 8 exclamation, or I'm sorry, over, yes, 5 exclamation point, 3 exclamation point. The reason is you just break it up because there's a 3 and there's left over 5. That would be 8 times 7 times 6 times 5 exclamation point. And I purposely stopped there because 5 factorial will be 5, 4, 3, 2, 1. And over here it's going to be 3 times 2 times 1 times 5 factorial because that'll be 5, 4, 3, 2, 1. Which means the easiest way to cancel it out is cross out these 5. And wait a second, 3 times 2 is 6. I could cross that out for a 6. Which means all I'm left with is 8 times 7, which is 56.
I don't know why you did that. Like from the start.
Is it because is it 5 and 3 so equals 8?
Yes.
So why did you choose 5 and 3 though?
Why?
This is a 3, so I put the 3 here, and then 5 is what you add to get to 8.
Why do you 8 over 8? Like why?
Why?
I don't want to jinx myself.
Yeah.
Last time I got an asthma attack.
Why is
during
there
the
an
test
8
where I
on
said
the
this,
top?
but I think I know.
Say again?
Why is there an 8 on the top and a 5 and a 3?
So the first number, which is your total amount, is 8. Okay. Shh. The 8 is the total, so I put that on top. The 3 is... Yes. So 3 and then 5 adds up to 8. All right, I cross that out. But again, let's say you're very scared of exclamation points. You could go to your calculator. Then you go to the button math. You're going to the option probability. So go right to probability. Then I'm going to go to option 3, which is NCR. I press number 3, or you can scroll down. If you have an older version, you might have to put the number first. Then you press 8, go right. You press 3, lo and behold, you also get 56. Yes.
Does that mean you don't have to show your work?
Yes.
Yay!
Next one. Well, for this one, you don't have to show your work. Next one. Good. Let's say there's a situation where I have a 10 question test, okay? And this is true or let's say true and false. So, what's the chances when you guess on a true or false question?
50%.
Good. So, that means I have 50%. My probability is 0.5 for getting it right. What is my probability of not getting it right? Also 0.5. 1 minus p, yeah. Which is your not probability, or your complement, should we call it. All right. With that in mind, let's say on this test, you want to get lucky. Let's say you want to get, actually, let's see what's typical. Let's say you expect to get, what's the chances of you getting at least 30? No, at most 30. Yeah, 30 or smaller, right? So we want, so how many questions will we need right to get 30 or less? And? 2 or 1 or 0. Okay? So in this situation, I want at most 30%. Like, I don't know, let's say the scenario, I can make up a scenario.
I'm also wondering on the top one, the first question we did, how come you only do 8 times 7 times 6 times 5? Why don't you go on to 4 3 2 1?
One more time, because this 5 exclamation point is the bigger one. And instead of writing 5, 4, 3, 2, 1, and writing down here 5, 4, 3, 2, 1, I just cross it out as 5 exclamation point, make my life easier. Yeah. You're going to cancel them out anyway, save yourself time. All right. So this one, we're going to use this formula, which is, let me use the correct letters. NCK, probability to the K amount, times, and 1 minus P to the N minus K. You need to write this out, yeah. No, this is what it is. This is.
Is that times?
Yeah, they're times. So this one is just the combination of winning and losing. So N being your total, and K is what you're looking for, or your wins. Usually I say winning, but it's also preferred. You might see it. So this one, the PK, is just your probability of winning to the power of how many times you win, or numbers of wins. Well, this one, the next one, it's just your probability of, if you're not winning, you're losing. So this is your probability of losing. And then the number of times you lose. So in this case, I want 3, 2, 1, and 0. So I want to do, let's do 3 for now. So 3, choose, I'm sorry, other way around. I have a 10-question test, and I choose 3 of them. The probability of me getting it right is 0.5 to the power of 3, because I want 3 of them right. If I get 3 of them right, that must mean I got 3 minus, or 10 minus 3, or 7 of them wrong.
We have to remember this one, man.
Yes.
Not everybody.
On the final, you give
No. Yes. On the final, I'll give you formulas.
Are you gonna ask like behind this? Like,
Can we get all
if I
the
know how to
choices
set
to
that up,
answers?
is that fine?
No law.
One question at a time. Ethan?
If I just know how to like set that up, are you gonna like make me remember when to do it on this test? Or are you gonna kind of like set it do that then?
It's going to be in this order, and it's going to be obvious because it's the only one that would make sense for this.
Okay.
Because the other ones will say do a curve, and the other one will say do the margin of
So
error.
what
So
info do you even get to us? Just the amount of questions?
I have to give you the amount of questions, what type of question, or the scenario of the situation. And then that's actually all I have to give you. Because this formula you use, and the probability, it could be figured out by knowing it's a true false, or knowing it's a 4 option, 5 option. All right, so you do this, you type this in your calculator. But wait a second, there's a shorter way to write this. This is 0.5 to the 3 power, this is 0.5 to the 7 power. So what we can do is rewrite it as 10C3 times 0.5 to the 10 power, okay? 0.5 to the 10 power.
Can we ever review how to put it into a calculator?
That's a good idea. So we're going to take the calculator. I'm going to put 10 first. If you have an older version, you have to put it in first.
Then you hit math.
Math, go to probability. Option number 3, NCR.
Is it always NCR?
Yeah.
Yes, NCR on this test.
Then you put 3.
Then with 3,
So
And we're gonna-
Mr. Gilby, you first
Yes.
write the 10 in the calculator, then you press the NCR thing?
yes. Oh, if you have an older version. If you have a newer version, you can put it in after.
Oh, do I have to click multiple? Like, do I have to click the arrow after the next number? But after
Yeah, you got to click right, so it goes away. So then I could times 0.5. Remember, I shorthanded it to the 10th power. Now remember, this is a decimal. I want a percent. So what's the percentage here?
11.
11. Let's go 11.7. Okay.
Wait, wouldn't it be 12 though? 'Cause-
No, 11.7 is better. So this is 11.7%. Okay, 11.7%. I get exactly 3. But was that my question to get exactly 3?
No.
No. What do I want?
What? At least 3.
At most
I
30%.
know, so you also have to do 1.
Good. So if this is 11%, I'm going to do the same thing now for 2. What's the difference here? Well, 10.
Changing the 3 to 2.
We're changing the 3 to 2 because even though, guys, even though this is changing, this is 2 times 0.5, 8, because 8 losses now. In this case, they still combine to 10. So the only thing I change, and this works particularly because it's a 50-50, is the 2 in the C. Otherwise, it's almost the same thing. So we're going to do the same problem, but in this case, we're choosing 2.
Can I just skip like the writing of like times?
As long as you write it one time, I'm good.
I'm saying for the second and the 8 is 2.
Yeah, exactly. Yeah, you could do that. 2 times 0.5 to the power of 10. So this case is 4.4%.
Yeah. Tomorrow's rounding off the third number.
Just go to the, I guess the third number or the 1 decimal point of it. Nearest 10th of a percent, which is the third number you're at. All right, do it for 1, which is going to be 10C1
So the 10.
2.5 to the 10th power. So if you want to make it easier, just press second enter, and you'll pop up what your previous thing is. And then I'll just go left until I get to the 2 and replace it with 1. This is 0.9%.
Would you write 1 there or no?
Yeah, actually it rounds up to 1. So let's say 1%.
Would you take off if you did 0.9 on that?
Nah, I wouldn't, but I should be consistent with my rules from before. And then we also need to figure out what's the chances of you getting none of them right. So 10 choose 0 times 0.5 to the 10th power. So again, to make my life easier, I click second entry and just go right until I hit 0. Or I hit the 1 and replace it with 0.
Probably gonna get small.
Very small number. So if you ever get something like this means like 10 to the negative 4th power. So if you want to change it to percent, just times it by 100 to make your life easier. This is the percent. So your percent is 0.01. No. This is the actual percent.
But look at it. It's this,
Yeah. So it's 0.1%. Or what is it? 10%, I guess. No, 0.1%. Let's just round it up. Yeah.
But then let's say some numbers I got. Well, let's say
On the test, it won't be anything worse than that. Okay. All right. Either way, now what's the chances of him getting? What do we say? At most 3.
yeah.
Yeah. 11.7 plus 4.4
You got all of them.
plus 1
This question
plus
will only
0.1.
take 20 minutes.
If you don't pay attention, it will. So this one is
That would be
2.
17.1. I think.
Carry the 1 over you. No,
16.
16. Yeah. No, this one 17.
0.1%.
I thought it's 17.
It's 17. You forgot this one. I forgot that one too. 17.2%.
They have 17.2.
Hmm.
How do you 17?
11 plus 4 is 15. Plus 1, 16. Carry 1 over, 17.
Right.
So 17.2% is the chance that he'll get 30 or less, or 30% or less, like 30 grade. Another way you could think about it, the chance of you getting more than 30% would be 100 minus 17, which is like 83%, which is not too bad.
So what do you think my chances are of getting a 90 on this test?
Pretty high.
No. We need to do like an actual calculation of that.
Then we need the probability of him, but is he guessing on every question?
No, I'm like doing the math.
So I can't do it because it only works
Oh,
if
fine, I'll ask you better. Not because you'll know this answer. Me getting an 89. Because you always get an 89.
100%. All right. Next
So if
one.
you're sure you're working, you're automatically get points.
Yes. Yes. That's always been the secret. All right. Next one. Let's say you have a multiple choice question. You have 4 choices. Choice. 4 options. So there's 4 options on the test, and let's say you're guessing on 6 of them. What's the chances you get exactly 2 right or correct? Well, let's figure it out. So you're still using the same formula. There are 6 questions in total, so it's 6 choose 2. Now the probability of getting an option correct guessing from a 4 options question, like a multiple choice. So 25%. So we're going to put 0.25. And since I'm looking to get 2 right, I'm going to put the number 2, power 2 on there. Times, in this case, let's say what's the chance of you getting it wrong?
25%.
No, that's the chance of
no,
getting it right.
25%.
It's the leftover, 75%. Or 0.75 to the 4th period. Oh, sorry. You had your hand up for a little bit. Go ahead.
No, I
Okay. All right. So in this one, I cannot combine them because they're not the same number. So I'm just going to have to type it out. So 6 choose 2 times 0.25 to the power of 2 times 0.75. Remember, it's just you're losing. It says 1 minus p. That's just the percent you're losing to the 4th power. So it looks like to get exactly 2 out of the 6 question rights, he has a 29.7% chance.
times 100, that would be 2.9, wouldn't it?
times 100 would be 29.66, which is 29.7.
I can go around to 30 then.
Let's go to a tenth of the percent. But again, if you round wrong, I'm not gonna go crazy.
So just take off like -5.
Mine is a 0.5 probably.
9.1.
Yeah, it is. All right. Next one. I'll probably have some words with it, but we're gonna do a standard curve where your x bar is, let's do 72, and your standard deviation is, I don't know, 10, sure. You got it, Shank? 29.7%, okay? All right, and let's say the standard deviation is 10.
Wait, what's X bar again?
X bar is the median or the mean.
What's the difference between the two?
In a standard curve, nothing. In a normal situation, the mean is the average.
You give us this, right?
I have to give you this, I have to give you this, and I'm going to have a blank one for you to fill in.
And you have to know the numbers that come.
So I'll show you what to do. 1, 2, 3, 1, 2, 3. Okay.
What's bars?
X bar, that's the mean.
No. The button on the calculator bars.
I'll show you what to use that soon. All right. So you're going to fill in the curve. So this curve is 72. And then we go up 82, 92, 102. I am adding the standard deviation when I go to the right. In this case, the standard deviation is 10. So I add 10 each time. While here, I minus 10 each time. 62, 52, 42.
But I thought you give us numbers. I thought.
Yes. I guess I should have known this red. This will be, you have to fill this in. But everything else in black is,
No, but there's numbers. Like
yeah, these are the numbers.
percentages.
Oh, the percentages you need to know. Or you're going to use a calculator. I'll show you both. But the first set is 34%. The second one is 12.5.
Same numbers for everything, right?
Always, for a standard curve, this is always true.
Are we only doing standard?
What? Yes, this is only going to be a standard curve.
Is there a pattern to those numbers? Like
Yeah, 10.
Oh, you're talking about the purple numbers, I imagine he's talking about. Is there a pattern to it? I don't think there is particularly. It's just that this is 68%. The second two standard deviation is 95%, and three standard deviation is 99.7%. I don't know if that makes a pattern of any particular reason.
So it's just
What's with the arrow on the
68, 25, 4.7, 4.3.
Yeah.
I'm on the back.
All right. So I'm going to ask you questions like this. What's the probability of getting 52 through 72 if I pick somebody randomly? So I have to add this part and this part together.
It's only gonna be one question.
There'll be one curve, and I'll ask a couple questions from it.
46.5.
So this case is 44 plus 12, 46.5%. Yeah. Yeah, go.
I think
That's
what's
it?
related to the last one, and this one is the probability or whatever. Like,
Mm-hmm.
are we gonna have a question? Not only said like last time it was like exactly this number. Are we gonna have something that's
Yes.
We learn, like at least something. Like probability of getting at least or,
You'll see. So, like, for example, let's say if I want the probability of x is smaller than 82%, or 82, I should say, not 82%. So this means this is at most 82, which means I'm going to add all of these parts together.
Wait,
34 plus 2 is 36, or 46. So this one, less than 82. So that means everything here. But remember, to make your life easier, at the middle of the curve, it's 50%. This is automatically 50%.
plus 34.
So 50 plus 34, 84%.
That's a smart trick.
And then probability of x is bigger than, let's do it this way, where x is bigger than or equal to, let's say 92.
So we're just, isn't it
So you just add these two.
Isn't it just 2.5?
2.5%.
Make 15 though. So it's not like-
This is 0.15 though.
No, so 15 with 2.35 is 2.5 plus 12.5 is gonna make you.
I don't have 12.5. I'm at 92.
From 92.
No, the previous one.
Oh, the other one, sure, yeah.
Right, so that makes you 15%. So wouldn't the rest be
No, no,
85%?
Round up 6. You forgot to carry one over. 16. It'll be 16%.
0.5, 1.5.
Is everything less than 82? It's not including 82.
No. It should be this right here. You're saying should be 16%. It's 16%.
How? It's 12.5 plus 2.5. 2.35 plus 0.15. That's 2.5. And then plus 12.5. That's 15.
I'll figure it out later. I don't know why it's like that actually.
Hey, wait, let me
But you're correct. Yeah, it should actually be 16. We'll figure that out later.
So, was it 12.5 or 13.5? Because that would be 16.
Oh, maybe it is 13.5.
I knew it wasn't
That
lucky when I
adds
put
up to
13.5. I knew it.
That adds up to 15.
Yeah.
So the first one is 47.5.
Oh, okay, yeah. This is 13.5%.
Are you kidding me? I think you did 12.5 in all their lessons also.
Maybe not. I don't know.
No, I remember you writing 13.5.
If you write 13.5, 12.5, I won't give you any credit off. Either way, let's show how to do it with the calculator, okay?
I'm so confused now.
Nah, don't sweat it. All right. Here's how to do it with the calculator. Let's do this one first. From 52 to 72. Okay, you're going to go to here. And we're going to go to second vars over here. This is distribution. So second and vars, which is right next to clear. We're going to go to normal CDF. If you have an older version, I'll talk about it a little bit, but in the nicer versions, it's like this. In this situation, I have 52 to 72. So my lower bound is 52, and my upper bound is 72. Now, this mu is called the mu, or the mean, is going to be what the mean is in the question. Happens to be 72 in this one, so 72.
Is this what's in the middle?
Yeah, so in the middle.
Okay.
And then the standard deviation in this question happens to be 10. So we're going to click paste.
Wait, what's upper then?
Where you're going up to, which in the first question is 72. They just happen to be the same.
What do those numbers mean now? Let me just go.
Okay, so this is the lower bound, 52, upper bound, median or middle, and the standard deviation.
Okay.
Now, if you have an old calculator, you just have to put it in like that with commas. Either way, you press enter, 47.7%, which is close to ours. It's giving us an exact number, that's why it's a little different. But it's close to what we got, so 47.7%.
How come was like
So you could just do the calculator for every single thing.
That's what I've been saying the whole
So you don't
time.
have to show work.
Wait, can we
right?
graph it on like?
You have to fill in the curve, but you don't have to
It's
show
not
work
manipulative.
afterwards.
I don't like do like
Yeah.
minus
Wait, then
one.
how come this gives 47.5 and this one gives 47.7?
This is giving you an exact number that is doing a calculator, like literally
What
counted.
did we get earlier? 47.5.
These are all estimates.
These
Yeah,
are all-
the purples are estimates.
Is there a way to graph this on like a phone?
Not in a way that's useful, I don't think so. Not that I know of. Right now, not that I can think of. All right, next one. We have something smaller than 82. So in this case, when we do normal CDF, for our lower, we need something really smaller because it can't go to infinity. So I put something like negative a million or something. Doesn't matter how many.
Why do you do that?
Because I need to go to negative infinity. But the issue is, it can't go to negative infinity.
It doesn't matter what number you put.
It's just something small.
Then what?
Like, it's smaller, a lot smaller than mean. So like, you put 0, probably the same thing, but I just put negative, like a big number, just to make sure it's safe.
Okay, fine.
And then our upper in this case is 82. Luckily for us, our mean and our standard deviation is the same. Press enter, enter, 84-ish percent, 84-ish percent.
I graphed it to give you a straight line.
Yeah, you're just getting a number. That's why I don't know offhand what to graph. And then the other direction, second vars, normal CDF. In this case, I have an upper bound. So because I want something bigger than 92. So I plug in 92 here. While I'm going to plug in something really big, like, I don't know, 10,000, maybe a million.
Wait, why? Why like?
Because I need something really big to represent, yeah. Paste, enter, 2.27.
We got 2.5.
Yeah.
I got 2.25.
You got 2.25?
But how exactly on the percent do you want it to be?
Yeah. What's
How
up?
exactly on the percent do you want it to be?
For my answer sheet, I'll do both, and then let's see which
I
one.
read 2.5 on the test.
Oh, that's fine. Yeah. Wait, 2.5 from the calculator though?
No, if I like just did it.
Oh yeah, that's fine. That's fine. Okay. All right. Set us the standard curve. Either do it by hand or by calculator. I don't care.
That was what lesson was that?
6.3 or something?
Were we going to 6.4?
Yes, I believe.
2.5.
All right, next one's margin of error. The formula for margin of error. So the margin of error, capital M, is going to be 1 over plus or minus 1 over the square root of how many samples you took, which means the more samples you took, the smaller your margin of error. For example, if you took only one sample, as in you only asked one person, your margin of error is 100%. If you ask 2 people, or let's say 4 people, your margin of error is 50%. So the more people you ask, the better it is. So you're going to have both forward and backwards question. So I'm going to ask you, what's the margin of error when you survey 144 people? So in this case, if I ask you, if you survey 144 people, what's your margin of error? So plus or minus 1 over the square root of 144, which is plus or minus 1 over 12, which is, as a decimal,
Oh, you want that as a decimal?
is a percent. So yeah.
83%?
So 8.3%. So 8.3%. Plus or minus. All right, next one. I would ask you, hey, I have a margin of error. I want a margin of error of, I don't want a big margin of error. Let's say 4%. I only want a margin of error of 4%. How many people do I have to ask in order to get a margin of error of 4%? So in this one, I'm going to set it up where 4% or 0.04, make sure you convert it or you're going to get some crazy number. You're going to get like a decimal, which doesn't make sense in this situation. Equals plus or minus, mathematically the plus or minus doesn't really do anything, the square root of n. So I'm going to times square root n on both sides. So 0.04, the square root of n, equals 1. Then I'm going to divide 0.04 on both sides. So the square root n equals 1 divided by 0.04. And then I'm going to square both sides. So, exactly. To the square. So I just go to my calculator. Parentheses, 1 divided by 0.04 squared. 625. This happens to be a whole number. So this is 625%, or 625 people, I should say. You have to ask. If you get a decimal, like for example, this is the one-time rounding actually matters, I guess.
You can't have half a person.
Yeah, let's say you get a decimal like 637, 2.7. Or
633.
this is going to have to be round up 633. Now if you,
That number, that's just wrong.
yeah, because you can't ask 0.7 of a person. But if it was like 642.1, I need to ask 643 people. You always round up.
No matter what.
Yes, because you need to hit that number.
If it's 6.5,
You round up.
so around that.
Always round up. In this situation. Because it's kind of like, you remember those questions like, you have a table that seats 8 people, and you have 20 people. How many tables do you need?
Something in the math. 3.
You need 3 tables, because you have to round up. Even if you had, let's say, 17 people, let's say, right? It'll be 8, 8, and then 1 person. You can't have a 0.1/8 of a table, so you still need 3 tables. It's that kind of concept. I think that's it, because we don't do C-score.
Wait, don't you say that?
Yeah.
Alright, so that's our last test review of the year, except for finals.